We will now do problem 4, given in the spring exam of 2017. So here we have the velocity of a ship given on component form, and we're going to work with magnitudes and angles. So let's jump right into A. So here we have the velocity of a ship given on component form. So I points east and J points north. So this would be 6 knots in east direction and -8 in J direction, or 8 in -J direction. So it would be 6 south, not east, and 8 south. So this would be our V. Notice that my vectors will be in bold when they are printed, but when I write it by hand, it's easier to make an arrow above. Okay, so this is my V. Determine the magnitude of V and the heading. Well, the magnitude, that is what we call absolute value of V, or it's simply V without the arrow. That's simply the magnitude. And we use Pythagoras to find that. That would be 36 plus 64, which would be 100, so this will be 10 knots. The angle, or the heading. So now we want the angle clockwise from north. So this would be north. So we want this angle here. In order to find that, we need to use tangent. Let's call this angle theta. And theta would be only the one here, because tangents or inverse tangent would only give us something between -90 and 90. So tangents to theta would then be the opposite side divided by the adjacent side. So we make a triangle and we find those values. So theta would be tangent inverse of 8 divided by 6, which would be approximately 53.1 degrees. So it lies between -90 and 90, as we suspected. But the heading that we're looking for, let's call that alpha. So alpha would be 90 degrees plus this theta. So the first 90 and then the theta. That would make up our alpha. So that would be 90 plus 53.1 degrees, so approximately 143.1 degree. Okay, in B, the velocity vector is changed 45 degrees to starboard. So we started out with an angle. So we have east, north, south, and west. Started out with something like this. And now we are turning it 45 degrees to a new velocity, and the magnitude is doubled. Determine the new velocity in component form. Okay, so our new heading relative to north would be our last one plus 45 degrees. So 143.1 degree plus 45 degrees would be 188.1 degrees. So a little bit west instead of east, but mainly south. And our magnitude is doubled. So our new V, or V, would be 2 times 10 that we had in A. Okay, so it's 20 knots. So here we have our answer, but we are asked to find the new velocity in component form. And component form is not given with knots and a heading. That's magnitude and degrees. So our V, our new V, would be 20 times sinus to beta in I direction plus a cosinus to beta in J direction. So our V would be 20, and if we insert the 188 stuff, oops, like this, we get, just need to put it into my calculator, minus 2.8 in I and minus 19.8 in J. So that would be our component form, because component form means that we need to know how much in X and Y direction. Or here, east and north. So what we're saying here that it's westward and east. No, not east, sorry, south. Yeah. Because I is east and we have a minus, so that becomes west. And J is north and we have a minus, so that becomes south. And it also makes sense with the numbers because we have a magnitude of 20 knots and most of that is directed in the south direction. Just a little bit in the westward. And that makes sense since the angle is very, very close to 180, which is directly south. Okay, we now look at a region with a water current velocity. So we have a water current here. The velocity of a ship relative to ground is given as v plus v1 plus v2. Where v2 is the velocity of a ship. So we have the ship, and we have the water, and then we get the velocity of a ship relative to ground. So determine the velocity relative to the water. So we know we want v2. That will result in a velocity relative to ground of v. So we have v equals to what we have in the water plus the ship relative to water. And we know what it is to the ground. So here it's 3I minus 2J. V1 we also know, so we could put that in here. And then we have the V2, which we want to decide on. Okay, so what we need to do then is to put everything except the V2 to the left-hand side. So we had 3I minus 2j equals to 0. Oh, I wanted to move that to the other side. So I get plus and minus. Okay, just to repeat ourselves a bit. The vector I is a unit vector in the x direction. So it has the length 1 and is directed along the x-axis, or here east. J is a unit vector which also has length 1 but is directed in the y direction, or here north. So we cannot add something going east with something going in the south or north direction. We can only add east to east and north to north. So here we have 3I plus 0.5I. So those can be added. And we have minus 2j and then minus 1j. So those can be added. So that would be our V2. We're not asked to represent it in any particular form. So this would be in the component form, and that would be okay. So we have a ship, just to make sure here that you understand. So we have a ship, let's put it like this. And that ship is dragged by water, something half to the east and 1 to the north. So this would be our dragging by water. And the ship itself would be moving a lot more in this direction here. 1, 2, 3, 1, 2. This would be the relative one. And this one would be the ship's one. So instead of going in this speed here that we thought we would, and we would have done if the water was still, we're moving in this direction here because of the water dragging the ship a little bit back and northwards.